Hi, I'm Nicolai Buch Jensen, and I made this Book Scientific Calculator version 1.0 as an assignment for the Procedural Programming PP course. As you can see at the left screen, I have the calculator as it looks like. It has a short introduction, welcome to Book Scientific Calculator version 1.0, and a list of functions that I can run in the lower space. Right after the list, there is the result, which is 1000. I set it to 1000 at first. It's actually set to 0.0 at the beginning, but I already wrote something before I started this presentation. Then you can write a calculation and press enter as it says at the bottom. Let's write plus 1000 as well. And then it adds up to the result, and you can modify the result further on by adding more or maybe subtracting 1000. You can also multiply, let's say we multiply with 4, then we have 8000, then we can divide with 500, let's say 500. We have 16, also we can use modulus. Let's take 5, it should give 1, yep, it did. And then you have the delete remainder. Let's take the sinus and cosinus and tangents first. It's pretty much the same thing. We can write s. Then it takes the sinus of the 1. It's that's that number. And with the I, you can remove any decimals and round it down or up, depending on its if it's 0.49 or 0.51, for instance. This gives 0. You can also take the square root. Let's take 9. Take the square root of 9. Root. It's 3. And to the power of, let's add it to 3. It's 27. And you can exit program. Let's get into the code. Up here we have the include functions, which includes pretty much the basic stuff for IOStream, CSTDlib. Then it includes IOmanip, which is something you have to include if you want the user to write in a field you made for them. For instance, here you can write any kind of stuff. Alright, then we have the math.h, which contains the basic math functions, such as sinus, cosinus, tangent, square root, to the power of, etc. Then we define pi to be what it is, 3.14, etc., etc. And then we have the integer main, which is our main function. It contains a for loop, a switch, and the variables, which is the screen value. That's a long double, for instance. Which are set to 0.0, like I said, it's the result. It's already 0.0 at the beginning, and that's the screen value. That's the thing you have to influence on when you type in the plus or something or whatever you do. The num is actually the thing that influences, I will get back to that. That's the number you have to write down here. Let's say 102. And the options is the switch. It actually takes the num1 and make it possible to make a screen value of it. Yeah. The for loop contains actually pretty much the basic design right here. That's what you can see down here, over here at the left. And then you can type, then there is the result, which points to the screen value, which is the result. And here you can write in the C input the options, which is the switch, which I will get to right now. The case E, which is clear display, sets the screen value to 0.0, ergo the result. The plus, minus, divide and multiply is basically the same. At the top you have the what do you want to add, which I just showed. If you just write plus, for instance, it asks you what do you want to add, and then you have to write a number. You don't have to do that though. You can also just type in plus something something something, and then it adds the number to it. It says the screen value to screen value plus num1, which is the long double variable, and then it makes it into the screen value. Yeah, the divide, I had to make an if function because it cannot divide 0. So that's why I had to say impossible when it is 0, when the screen value is 0, ergo the result, when you then multiply it with something. You can't do that. I cannot show you on the screen because you can actually read it because of some function I made later on. I will get back to that. Then we have the modulus, which is actually kind of interesting because you cannot use the modulus with a long double or a double for that sake. So you have to make an integer that is actually equal to the screen value that I have in the double. So I made an integer called new screen value and set it to the screen value and made a new number that you have to write as an input, C input. And then I set the screen value to be the new screen value in modulus with num2. And the I could use a ceil function or a floor function to round it up or down and just use that, for instance. But I wanted to make sure that it rounds up when it's above 0.50 and down when it's below 0.50. So I made a if function that says if the screen value is not equal to the screen value plus 0.5, then it have to use the ceiling. That means if the screen value is 2.6, for instance, then when it rounds up, it's 3. But if it's plus 0.5, then it's 3.1, and then it rounds up to 4. Then the ceil screen value is not equal to the other, and that will make it ceil screen value. And if not, if it's 2.4, for instance, then it's 2.9 if it's plus 0.5, and that will make it both 3, and that will make it floor. And that's exactly the effect I wanted to give it. Then we have the S, the C and the T, tangent, sinus and cosinus, which is a basic function that it's actually just taken from the book. It's a sinus of a screen value multiplied with pi divided with 180. 180 is for degrees. I can also take it for radians, but I will not get into that. And that's the same with cosinus and tangents. That's pretty basic. The square root of something is actually just the same. It's a basic function that I got from the book. And the same with the uppercase, the power to the power of. The interesting thing about square root is that it's if it's below a negative number, if it's a negative number, then it has to be impossible, like it says impossible. That's why I have to make it an if function, telling whether or not it's a negative number. And if it's a positive number, then it have to do the calculation. The exit function is also pretty basic, Q, and the default is also kinda basic. If it's a default, then if it's right, for instance, an A, then it says, what are you doing? You can't actually see it because of this function, system CLS. Like I said before, it deletes the entire display actually. The whole calculator, it displays it all and remembers the result, and then it replaces it with the same calculator, and it's pretty good. But it also deletes, for instance, impossible and what are you doing and all that kind of stuff. That's pretty much it. Thank you for watching. Have a good day.